World Brigade. My name is Brayan García, and I am joined by my colleague Robert Caicedo. Today, we are here to present the topic of computer system with the purpose of providing a general overview. Element of a computer system: processor. It is responsible for controlling the operation of the computer and performing its data processing functions. Main memory. The main memory serves the purpose of storing data and programs, but it's important to note that it's a form of valid memory. This means that when the computer is turned off, the content stored in this memory is completely erased. Input-output modules, also known as input-output device, server and essential role be facilitating the transference of data between the computer and its external environment. These components act as intermediaries that enable the computer to effectively interact with peripherals, a storage device, network, and other systems. System bus. System bus is provides communication between processors, main memory, and I/O modules.
Computer components top-level view. One of the fundamental tasks of the processor is to facilitate the exchange of information with memory. To accomplish this, it typically utilizes two internal registers. The memory address register MER, which specifies the specific location in memory to read from or written to, and the memory buffer register MBR, which stores the data to be written to memory or receive data read from it. There is an EO address register EOAR that point to a specific EO device. An EO buffer register EOBR is used for data exchange between an EO module and the processor. On the other hand, an EO module is responsible for transferring data between external device and the processor, as well as memory, using internal buffer or to temporarily store data before transmission. Basic instruction cycle. The processing required for a single instruction is called an instruction cycle. It consists of two stages known as the first stage and the execution. At the beginning of each instruction cycle, the processor retrieves an instruction from memory. Typically, the program counter stores the address of the next instruction to be fetched. Unless otherwise specified, the processor always increments the value of the PC after each instruction fetch to obtain the next instruction in sequence. The retrieve instruction is loaded into the instruction register. This instruction includes bits that describe the action the processor must perform. The processor interprets the instruction and queries out the required action.
Program execution. In this example, we are executing a program that performs addition. The process is divided into three instructions called is completion, a fetch stage, and a execution stage. This process involves the utilization of internal CPU registers such as the instruction register IR, the accumulator HC, the memory address register MAR, and the memory buffer register MBR. Classes of interrupts. Program interruptions due to unusual condition. These are emergency signals that occur when something goes wrong, such as mathematical error or attempts to do prohibited thing on the computer. Timer interruption. These are scheduled reminders that allow the system to perform planned tasks at specific terms. Input-output interruption. They are generated when input-output device report the completion of an operation or problems such as paper jams in a printer. Hardware failures indicate serious physical issues like power outages or error in the computer memory.
The dashed line represents the execution sequence followed by the processor. When the user program encounters the first write instruction, it is interrupted and execution moves to the EO program. Once the EO program completes its task, execution returns to the user program. Right after the write instruction, this is because the EO operation can, can be quite slow, resulting in a significant pause in the execution of the user program. Now let's talk about interruption. Interruptions are mechanisms that allow the processor to perform other tasks while an IO operation is taking place. Let's imagine the control flow in Imagine B. When the user program reaches a point where it needs to perform a write operation, the corresponding EO program is activated. This EO program mainly consists of preparation code and EO command. After executing this instruction, control returns to the user program. Meanwhile, an external device is busy transferring data between the computer's memory and performing the printing. Instruction cycle which interrupts. In the interruption phase, the processor checks whether any interruption have occurred, which is signaled by interruption signal. If there are no pending interruption, the processor proceeds to the retrieval phase and looks for the next instruction in the current program. If there is a pending interruption, the processor temporarily holds the execution of the current program and proceeds to execute an interruption handling routine. Typically, this routine is part of the operating system and usually determines the nature of the interruption and carries out the necessary actions. Once the interruption handling routine is complete, the processor can resume the execution of the user's program at the interruption point.
Imagine you are using a computer and an external device, like a printer finishes an important task. The situation, the following steps occur. Device signals the computer processor that it has finished a task. The processor detects the interruption, acknowledges it, and allows the device to clear it. The processor stores vital information about the running program, like the position and states in a control stack. Then the processor finds the location of a special routine for handling this type of interruption. The processor starts execution this routine, which might involve a specific task related to the interruption, like handling input-output date. After finishing the handling routine, the previous program state is restored, including register contents and the current program position. Finally, the processor continues running the interrupted program from where it stopped. Conclusions. Imagine that handling interruption smartly is like a superpower that allows you to multitask and ensures everything runs smoothly when interacting with a computer. Too, in the world of computing, it is all about how different pieces, like the process, memory, and the ways of interaction input-output device come together to run programs. Understanding these concepts is of paramount importance as they are essential for designing effective computer systems.